we're going to work problem B2A together. So don't think, oh, there's only 2 problems for homework, I can do this in 5 minutes. No. Remember, the more you write down on paper, the easier it's going to be to solve your problems. You don't have to take shortcuts. So it says 3-point charges, Q1, Q2, and Q3. Oh, that's the wrong problem. 4 charged particles are placed so that each particle is the corner of a square. The first thing I'm going to do is I'm going to draw my picture. The sides of the square are 15 centimeters, and it says the charge at the upper left corner is +3 microcoulombs. The charge at the upper right corner is -6 microcoulombs, and the charge at the lower left is -2.4 microcoulombs, and the charge at the lower right is -9. What is the net electric force on the 3 microcoulomb charge? So first of all, I can't do anything till I draw my picture. So let me write my given. And the distance between each of them is 15 centimeters. So remember, we're going to have to put this in our basic unit, which is meters. And it's going to be 0.15 meters. So it's the same for all of them. Now, I'm going to start numbering the charges. I'm going to call them Q1, Q2, Q3, and Q4. So Q1, I'm going to call the 3 microcoulomb. Now remember, micro is 10 to the 6th power. So I'm going to write it without my prefix now. So when I put it in my calculator, it's ready to go. 3 times 10 to the -6 coulombs. Q2 is equal to -6 microcoulombs, which is -6 times 10 to the -6. Q3 is equal to -2.4 microcoulombs, which is -2.4 times 10 to the -6. And then Q4 is equal to -9 microcoulombs, which is -9 times 10 to the -6 coulombs. Now, remember, this is a square, so all the distances are the same. So R12 is equal to R24, is R34, R13, and that's 0.15 meters. The most important part is going to be to draw my picture. So now I have to carefully read where is each charge in this square. So the diagram is going to help me with this. So first here, I have the 3 microcoulomb one, which I called Q1. So this is 3 microcoulombs. Then over here, this is Q2, and this is -6 microcoulombs. Then over here, this is this is Q3, and this is -2.4 microcoulombs. And then over here, this is Q4, and this is -9 microcoulombs. Now remember, they told me that this distance here, because it's a square, each one of those, remember, is 0.15 meters. So what we're going to do is we're going to use Coulomb's law to find the distance in between all the charges. And for A, it says, what is the net electric force on the 3 microcoulomb what is on the +3 microcoulomb charge, which is Q1? Okay, so where's Q1? Q1 is up here. Okay, so when we're looking at Q1, and instead of doing it on my diagram, because I'm going to need this diagram for the other 2 parts, I'll just do it to the side. So here's Q1, and I know it's positive. Now there's a force between Q1 and Q2. Now this is positive, and this is negative, so it's a force of attraction, right? Because they're unlike. So that force, F12, is going to go this way. Now there's also a force between 1 and 3. These are also different, so that's also going to be a force of attraction. So I'm going to have F13 like this. Then there's a force between 1 and 4, and this is also negative, so it's also going to be a force of attraction. So this is going to be F14. Now, the only thing is, between these two, I already know the distance is 0.15. I know the distance here is 0.15. Is this distance here 0.15? No. So I could go ahead and find that distance right now, just so I have it done with. So R14, that's the difference between 1 and 4. We can see that this is an isosceles triangle, and I would use the Pythagorean theorem. So that's just equal to the square root of 0.15 meters squared plus 0.15 meters squared. And the reason I'm doing this ahead of time is so I don't make a mistake. Yeah, I'm writing more down, but if I do it step by step, it's really not bad at all. So when I put that in my calculator, that comes out to be 0.21 meters. All right, so how do I solve this problem? I use Coulomb's law to find this force, and this force. And after I find all those forces, what I do is I can put it in a table and then find the F total X and F total Y. All right, so let's start doing that. So we'll start with F13. Or, no, we'll do F12 because that was the first one I did here. Okay, so F12 is going to be K Q1 Q2 over R squared. So it's going to be 9 times 10 to the 9 Newton meter squared per Coulomb squared times Q1, which is 3.0 times 10 to the negative 6 coulombs, times negative 6.0 times 10 to the negative 6 coulombs, divided by the distance between them, 0.15 meters squared. So when I do that in my calculator, F12 comes out to be 7.2 newtons. So that's 1/4. So after I find F12, I'm going to find F13, and then I'm going to find F14. All right, so F13 is going to be K Q1 Q3 over R squared. So it's going to be 9 times 10 to the 9 Newton meter squared per Coulomb squared times Q1, which is 3 times 10 to the negative 6 coulombs. And remember, this, I forgot the negative here. This is negative. And the negative sign basically tells me that it's a force of attraction also. But I need to know my signs later when I'm adding them up. Now, so F13 is negative 2.4 times 10 to the negative 6 coulombs divided by 0.15 meters squared. So when you do all this, this should come out to be 2.9 newtons. And again, the negative sign doesn't tell you the direction, it just tells you if it's attractive or repulsive. And then the last one we're going to do is F14. So F14 is equal to K Q1 Q4 over R14 squared. So remember, now R14 is different. So this is going to be 9 times 10 to the 9 Newton meter squared per Coulomb squared times Q1, 3 times 10 to the negative 6 times Q4, which is 9 times 10, negative 9 times 10 to the negative 6, divided by. Now remember, the distance between these two is not 0.15. That's what we found here. Divided by 0.21 meters squared. And when we do all that, this comes out to be 5.5 newtons. Now, I want to add up all my x's and all my y's. The problem is, and if I do my chart now and write force, and then I do the x component, the y component, so I would have F12, F13, and F14. And then I'm going to have Fx and Fy, and once I find the total of Fx and Fy, then I can do my resultant. Alright, so if I look here, F12 is going to the right. It's all horizontal. It has no vertical component. Does everyone see that this force is only horizontal? So F12 goes to the right, it's only horizontal. Remember, when we're doing this, we have to establish our sign convention. So our sign convention is up and to the right is positive. So F12 looks like this. F12 has no vertical component, it's all horizontal. So F12, the y component, is going to be 0. And the x component is going to the right, which I call positive, so this is going to be 7.2 newtons. Now I'm going to look at F13. So F13 goes down. It's all vertical. F13 looks like this. So F13 has no horizontal component, and it's all vertical. Now, according to our sign convention, that's negative. It goes down, so I'm going to say it's negative 2.9 newtons. Now, F14, that one's not so easy. F14 looks like this. This is F14. In order to put it in chart form, I'm going to have to find, remember, now I'm going to do something called vector resolution. I'm going to find the horizontal and vertical components of that. And if that confuses you, you remember, it doesn't matter which way when I have F14. This is where I start. I go horizontal from the head of that vector. I draw the tail of the other. So whether this is F14Y, F14X, you see either way, F14X, F14Y, it looks the same. Alright, so now I want to find F14X and F14Y. Okay? So remember, this is a right triangle, and I need to find the X and Y component of each one. So F14X is equal to 5.5 newtons, that's F14, times the cosine of 45 degrees. How did I get that? Okay, well, this triangle I know is an isosceles triangle, and remember isosceles triangles are what? 45, 45, 90? Because it's an isosceles right triangle. So either way I do this, that angle there is 45 degrees because it's an isosceles right triangle. So F14X is equal to 5.5 because cosine is adjacent over hypotenuse. So when I put that in my calculator, I think that comes out to be 3.9. Let's see. 45 cosine times 5.5 is equal to 3.9. So this is 3.9 newtons. And then F14Y is 5.5 sine of 45. But luckily for me, sine and cosine of 45 is the same. So F14Y, the magnitude of it also comes out to be 3.9 newtons. Now this is the most important part. When you look at the picture, according to my sign convention, this is positive, so that's going to be positive 3.9. But the Y component points down, and according to my sign convention, that's going to be negative. So this is going to be negative 3.9 newtons. So now I'm going to add these up. So 7.2 and 3.9 is 11.1. I did that in my head. And then negative 2.9 minus 3.9 is going to be negative 6.8 newtons. So I'm almost there. Okay? So again, the only difference between this and what we did earlier in the year is instead of it being some other type of force, it's electrostatic force. So this is the X and Y component of my resultant. Okay? So now what I do is to find the resultant, I add them head to tail, and I use the Pythagorean theorem, and then I use definition of tangent to find the angle. So we're almost done. Now, I like to draw pictures because if you draw a picture, you won't make a mistake. Okay? So what we do now is, here's my two Fx. So Fx is 11.1 newtons, so I'm going to draw it like this. This is Fx. Or you can call it Ftx if you want for total. And this is 11.1. Now Fy is 6.8. So again, according to my sign convention, remember up and to the right is positive. From the head of this vector, I do the tail of the other, and this goes down. So this is the total Y, which is 6.8. And the negative sign, I drew it down. Now to get my resultant, from where I start to where I end up, I draw a line. And this is going to be my total. So to find my total now, and remember this is just F1 total, which we are finding. This is just part A. We're going to now take the square root of F1x squared plus F1y squared. So that's going to be equal to the square root of 11.1 squared plus negative 6.8 squared. So when I do that, F1 comes out to be 13 newtons. But remember that vectors have both magnitude and direction. So now I have to find the angle. Okay? So to find the angle, again, here's my picture. Here's my angle. Here's theta. Okay? Remember, this total is actually F1 total because we are just finding the forces on charge 1. This was the Y total, that was the X. So, definition of tangent. Tangent is opposite over adjacent, which is 6.8 newtons divided by 11.1. The newtons cancel. So now on my calculator, I say 6.8 divided by 11.1 equals, and that comes out to be 0.6126, but I don't want that. I want theta. So now I press second tan, and that angle there comes out to be 31 degrees. Actually comes out to be 32 degrees. Okay. Then I might have put an extra digit in there. This is not complete because I have to say from where. Well, I don't really have a frame of reference. You know, I can see that it comes down like this. So the way that I'm going to do it is I'm going to say F1 total is equal to 13 newtons at 31 degrees, and then because that's the angle I measured, I'm just going to say below the positive x-axis. So that's my answer for part A, and you still have to do B and C. Now, the reason why the other parts are going to be easy is I've already worked out a lot of the forces. Okay? So the other two parts are actually a lot easier. Now, obviously, you can't do this unless you have your diagram.